Hi, this is Hema from 4th year CSE. Now I'm going to do my 9th experiment in data mining lab, which is k-means clustering. So first I need a data set. I have Ripley data set over here. I'm just dragging and dropping it and then connecting it to the result and running it. So we have row number, label, attribute 1, attribute 2 as column names. Now we have to perform k-means clustering. So the operator which I'm going to use here is k-means clustering. I'm just dragging and dropping it. Actually, what is clustering? It is a process of partitioning a set of data into a set of meaningful subclasses called clusters. Here, similar objects are grouped in one cluster and dissimilar objects are grouped in another cluster based on the distance. In k-means clustering, it is a data mining or machine learning algorithm used to cluster the observations into a group of related observations without any prior knowledge about their relationships. The input here is the example set and the output is the cluster model. It tells which examples are part of which cluster. So I'm just connecting it to the result. I have a parameter here in clustering called k. It shows as like how much number of clusters we need to form. I'm just giving it as 2. I'm going to run it. So this is my output in k-means clustering. Here the ID column and the cluster column has been added. The ID attribute is used in distinguishing the examples clearly, and as I have mentioned, the value of k is 2. Two clusters have been formed, like cluster 0 and cluster 1. And cluster 0 has 131 items and cluster 1 has 119 items, and the total number of items in the Ripley set is 250. And this is how the cluster is formed. Blue dots indicates the cluster 0 and red dots indicates cluster 1. Now I'm going to do the k-means clustering with the performance. I have a Ripley data set over here and then k-means clustering. And the next operator which I'm going to use here is data to similarity. I have to see for the similarity measure among the data sets, so I'm using this data to similarity operator. And the last operator is the performance, which is cluster density performance. I'm just making the necessary connections. The output here is a performance vector, so I'm connecting it to the result. And this cluster model is connected to the input of the performance. So I'm going to run it. This is my output, which is a performance vector, and the average within the cluster distance is being given for the total and for cluster 0 and cluster 1. And the data to similarity operator, it generates a similarity measure object And this performance operator, which is cluster density performance operator, it evaluates the performance of this model and delivers a performance vector. And that's it about the experiment. Thank you for listening.